Hi everyone, it's Miss Berlanga, and this is the Check for Understanding Position, Distance, and Displacement PowerPoint. So basically what I'm trying to get you all to think about is how do we define the position, distance, and displacement of different objects? So at this point, we have already done the annotated reading for position, distance, and displacement, and you guys have also added those words to your science dictionary. So right now what we want to do is we want to take all that stuff that you've been learning about, and we want to see, can you apply it to some real life examples? So first thing I'm going to do is I'm going to give you all a problem. So this is kind of like a word problem that you would see in math. So Miss Berlanga, me, I'm walking down the hall. I started at my classroom and then I moved 5 meters to the right. So the question is what was my position when I started? And what was my position when I finished? So take a look at this number line right here and pause the video and see if you can figure out where would be a good place for me to start on this number line and where would be a good place for me to finish. Okay, so what we're gonna do is I'm gonna exit full screen real quick. And notice I've got these cute little Bitmojis of me. And what I'm gonna do is I'm actually going to put the start Bitmoji right here on the 0 line. So in physical science and physics, your initial position can really be anywhere you want it to be. However, the most convenient place is always going to be 0. Two reasons for that. 0 is the origin of a number line or the origin of an axis of a coordinate system like XY axis. But also, it just makes our math easier. So whenever we go to plug in numbers into the displacement formula, it's just going to be that much easier to use that formula. And then according to the problem, I moved 5 meters to the right. So my little finished Bitmoji should be right here, right on top of the 5 in this number line. So see, that was super easy. Remember that we defined position as having a direction, right? And remember that we can use a variable or a symbol to represent position. So in this next slide, I'm just showing you that initial position. We can write it kind of in a math form, right? So x0, or initial position, is at 0 meters. And then the final position, xf, is at plus 5 meters. So this is important because on the right-hand side of the number line, over here, these are positive numbers. On the left end, these are negative numbers. So you always want to make sure that your position has some kind of direction. All right, so the next one. What distance did I travel? So what is the total distance traveled? Go ahead and pause the video here and see if you can figure it out. Okay, so whenever you are trying to figure out the distance traveled, you can kind of trace with your finger along the number line, right? So I moved left to right, 1, 2, 3, 4, 5 meters. So looking at that answer, D, or distance traveled, is equal to 5 meters. And because here it doesn't matter the total direction, remember that the definition for distance or distance traveled, we just care about the total number of steps or the total length that we traveled, the total length of our path. We don't care in which direction we end up. So we only care about the total. So it's just D equals 5 meters. There is no sign right here. All right, so the next question is, what is my displacement? So in other words, how far did I end up from where I started and in what direction? Go ahead and pause the video here and see if you can figure it out. All right, so again, we want to kind of trace our finger along that number line, right? We started here at the 0, and we can trace all the way to the right over here where we finished up at 5. So in other words, we moved 5 meters to the right. So delta x, or our displacement, is positive 5 meters, or in other words, 5 meters to the right. There is another way to figure this out. So we can figure this out by kind of drawing an arrow or kind of tracing movement along a number line. But we can also use the equation that you all are already familiar with. So delta x, or displacement, is equal to the final position minus the initial position. So we take that plus 5 meters, our final position, we subtract 0 meters from that, and see what I meant earlier? This makes the math easier. So our final displacement was 5 meters in the positive direction, or positive 5 meters. All right, so we're going to go over one more example. This one is a little bit harder, and I definitely recommend that you take some pencil and paper and you work through this, you sketch it out as we go through the example, because this is going to be great practice for an assignment that you guys have coming up. All right, so I have a couple of Bitmojis here, but let's go through and read the problem. So Ms. Berlanga, I am leaving for the day. I started at my classroom and I moved 10 meters to the left. All of a sudden, I remember that I left my car keys in my room and I double back. I make it 4 meters down the hall when I find a magical bougie cat that gives me a hefty pile of cash and tells me to make it rain. So the first question is, what was my position when I started, when I doubled back, and when I finished? So again, I'm going to leave full screen so I can kind of drag these little Bitmojis around. So I started, and then I had to double back at some point, and then I finished somewhere else. So go ahead and pause the video and see if you can figure it out. Okay, so again, remember that the start, it's easier to place the start at 0 meters, right? Always easier to do that. And so if I traveled 10 meters to the left, I traveled in the negative direction. So I'm going to put the double back emoji over here by the 10. Okay, you can see my face. Ugh, really? Seriously? I got to double back. And then whenever I finished up, remember I had to go back to my room, and then I moved 4 meters back down the hallway in the original direction that I was traveling. And 4 meters is where I met this bougie cat, magical pile of cash, and I'm making it rain. So let's look at how we represent these with variables. So again, our initial position, gotta make sure I don't move that mouse. Sorry, y'all. Our initial position is 0 meters. The spot where I doubled back was negative 10 meters. So I went to the left, so the negative end of the number line. I ended up going back to my room, and then where I finished, where I met the bougie cat with the pile of cash, was 4 meters to the left of my room, because remember, I'm going back in the original direction where I was intending to go, and that final position is negative 4 meters. All right, so the next question is, what is the distance that I traveled? So go ahead and pause the video and see if you can figure this out. All right, so distance traveled, what we're going to do is we're going to consider each separate part of the journey. So initially I traveled 10 meters to the left. But remember that for our purposes, whenever we are adding up distances to get the total distance traveled, we don't care about directions, so we're just going to put down 10 meters. Then I moved another 10 meters back to my classroom. I grabbed my car keys. And then, and then I moved back down the hall. And this time I only made it 4 meters before I met the magical bougie cat with the pile of cash. So the total distance, I get that by just adding up the individual distances. So 10 plus 10 plus 10, sorry, 10 plus 10 plus 4 is 24. So a total of 24 meters. Okay, and now let's think about my displacement. So remember that for displacement, we only care about where we started and where we ended up. So go ahead and pause the video and see if you can figure this out. All right, so looking at this diagram, again, thinking about we only care about the start and the finish when we determine displacement. We can do this graphically, so we can kind of trace our finger or draw an arrow from the start position to the ending position. And so if we draw an arrow, we notice that we end up 4 meters to the left of our original position, or in other words, negative 4 meters. Or we could use our math. We could use this equation, again, the one that you're already familiar with. You're going to plug it in. You're going to plug in the final position, which remember, it's back in the position slide. -4 meters is our final position. We started at 0 meters. -4 minus 0 is just -4. So again, notice that the fact that we started out at 0 made our math just a ton easier. And those are two ways to get displacement, either graphically, so tracing along the number line or drawing an arrow, or you can do it mathematically. Ideally, you should be able to do both so that you can double check your work. All right, so that is it. Let me know if you have any questions. Definitely check this out. Go back and watch it again if at any point you were confused or if you got the wrong answer. All right, y'all. Talk to you later. Have a nice day.